Okay, so just started recording. Today is 10-1, 10-2. You guys just took a test on chapter 8. Again, as a whole, really all of our scores. So good job, you guys. That being said, you had no homework, so we're just going to jump right into today's lesson. My other class did a good job of answering questions when I asked them to, and then we had a little extra time at the end to work on homework. So anytime we get finished, I'll let us go, and so we can work on our homework and be all ready to go for next class. Okay, that being said, we're going to start with areas of parallelograms and triangles. Now, I believe these are things that you've already learned, but we're just going to review them, practice a few. And we really couldn't do this until today because there are some things from chapter 8 that I needed us to remember or use in this chapter. So area of a triangle, we'll start pretty easy there. And this is something that you, I'm sure, did back in middle school or elementary school. Area of a triangle is 1/2 base times height. So if I go looking at this picture, my base, it doesn't always have to be the bottom one. It's just whichever side we choose. The height, though, matters. So my height comes from a vertex that's opposite from my base side. And then it makes a 90-degree angle. It is perpendicular to the base side. Another word I use here is altitude. And we learned about altitude back in chapter 5. And altitudes, again, come from an angle to be perpendicular to the side opposite. So you need a height, you need an altitude, and that must be the same as being perpendicular to the side that we're calling the base. I don't need to know those two sides. Those are not important. Okay, area of a parallelogram is actually the same as a rectangle. So area of a parallelogram is just base times height. Again, any side can be my base. My height is just based on which side has my altitude, where's my height at from one of the vertex to the opposite side. Again, it's a perpendicular distance. All of these are perpendicular distances. Remember basic things about a parallelogram. This side and this side are congruent. This side and this side are congruent. Opposite angles are congruent. We've got, they all sum up, all my angles sum to 360 degrees, all that fun stuff. Now I'm gonna do a little notability magic. I've got this little triangle right here that's drawn because I have my height and I have my 90-degree angle. Now, what happens is we are using the same area as a rectangle. If I were to move this little triangle that's on one end over to the other side and just tape it to the other side of my parallelogram, and now just physically ignore this. I wish I could do this in person to just dramatically cut paper and tape it on. This triangle fills in the part that's missing in my parallelogram. So I now have a full rectangle, a height of H and then a base of B. You may not trust the base is the same, but if this is my distance for my base, and I again cut and paste that here, it's the same as the distance from one end of my new rectangle essentially to the other end. You don't need to do this, you don't need to prove this, but I think it's kind of cool to not just use a formula, but know why I get to use it. So I've got base times height, and it's because of if I were to chop this triangle off and tape it to the other side, I would have a rectangle. Okay, now we got some problems to do. So we didn't learn a lot of new things, but we are gonna practice a lot. And on each of these, I didn't mean to do that. Just threw my pen at my iPad. Okay, in each of these, we need to do area and we need to do perimeter for all of these shapes. And we can do it in whatever order we want. I actually might kind of skip around so we kind of do what's easiest first and then we'll do what's hard. So I'm gonna zoom in on this first shape. I've got a parallelogram here. I know that the bottom is 30, so that means that the top is also 30. And I know that one side is 15, which makes my other side 15. Oh, the easiest thing actually to do is just to do my perimeter. I'm gonna do perimeter by adding all the sides up. You can do perimeter in a couple different ways. You can do literally 15 plus 15 plus 30 plus 30. We could do 2 times 15 and then 2 times 30 and add those together. Or we could do 2 times 15 plus 30. Either way, whatever way you want to do it, these are all going to give us the same thing, and it's going to give us 90. I really need you to be careful of units here, so it's going to be 90 feet. Perimeter is just normal units, nothing squared, nothing cubed, just normal units to the first power, 90 feet. Anybody questions about that? Okay, next I'm going to do area. Before I do area though, I have to find my height, this distance right here. I'm going to separate out this little right triangle that I have here because I think that's going to be helpful to me. I've got a 90-degree angle. I know this is 15. The one other thing that I need to know here is that my angle is 45. My angle in that bottom right corner is 45, which makes its opposite angle also 45. That's too big. This is also 45, which makes the other angle in this triangle also 45. So now I've got this tiny 45, 45, 90-degree triangle. You guys just took a test on this. Does anyone remember how we go from the hypotenuse to the leg of a 45, 45, 90-degree triangle? Say that again.
Dividing by root 2.
I don't think I understood you. Say it one more time, Isaac. I'm so sorry.
Dividing by root 2.
Dividing by root 2, good. You're like, Zoom was jumping on the first one, and then the second one, I was like, I don't think he was wrong, but I also can't confirm. So divide by root 2, that's perfect. So if you're going from the hypotenuse to a leg, that's going from big to small, so we have to divide. And then I'm dividing by root 2. So I've got 15 divided by root 2. Don't forget to rationalize, so multiply by root 2 on top and bottom. I've got 15 root 2 over 2. Not the nicest answer, but it's not wrong either. It's totally fine. So I'm going to put that in for my height. I've got 15 root 2 over 2. That's my height. Now I have height and I have my base, so I'm going to do my area. I've got to do area, and we know for a parallelogram, it's base times height. So I have to do 30 times 15 root 2 over 2. 30 times 15 root 2 over 2. Now, my directions say express answer as a simplified radical. It doesn't say anything about decimals. I'm going to try and do it as a fraction first, and then I'll let it be a decimal, but this one's actually going to work out nicely to not even be a decimal because I see 30 and 2 have something in common. They both have a factor of 2, so it becomes 15, and I get to multiply the tops. 15 times 15 root 2, that's going to be 225 root 2. I don't want that as a decimal. I want that as 225 root 2, and my units here is feet. Area is always squared, so we're going to do feet squared. Okay, any questions on that one? We had to do some special right triangles, but then we solve pretty easily. Okay, let's do an example of triangles before I let you try a couple on your own. I've got a triangle here. Now, one thing that might be a little confusing is I've got this shaded part. This is what I'm finding the area of and the perimeter of. So it's not like in my last class, they were really concerned about like this little blank triangle. That's just there to help us out. So we technically don't need that. What we do need this for is to find this missing side right here. I don't know what this length is. And so I'm going to use the fact that one side is 3 and one is 5 to find this missing side. Does anyone know what method I use if I don't know the angles, but I just know sides to find the third side?
Pythagorean theorem.
Good, Allie, Pythagorean theorem. So I'm going to do 3 squared plus, we could just call this x squared, and then equals 5 squared. 5 is my c, so I got to make sure that that's by itself. So we'll do 3 squared plus x squared equals 5 squared. 3 squared is 9, x squared, and then 5 squared is 25. minus 9 from both sides, x squared equals 16. Oh, and then perfect. 16 is a perfect square, so that just equals 4. And get 4 right here. Okay. Now, before I find this last missing side, I actually can do area very easily here. I've got a right angle right here. So I've got a base, which is the whole shaded length. And then I've got a height, which goes from a vertex to be perpendicular to the opposite side, which is 4. So I'm actually going to do my area really quickly. I don't need to do anything else in order to find this. And so I want us to get in the habit of not over finding things. If my question only said find the area, we don't even care what this side is. Since we're doing perimeter, we do care, but like if we weren't, we wouldn't care. So I'm going to do area, and then we'll find that missing side so we can do perimeter. Area equals 1/2 base, which is 15, times height, which is 4. I do see again a common factor. So you can think of this as 15 over 1 and 4 over 1. The 2 and the 4 have a common factor of 2, so I cancel that out. And then that just leaves me with 15 times 2, which is going to be 30. So my area is 30 centimeters squared. Anybody questions yet? Yeah, I think this is pretty simple. This is probably what you've been dying to do since we started geometry. You're like, I thought this was what geometry was, and then Miss White gave us a bunch of other crap. No, this is stuff that you've kind of seen before, but now we're adding this other thing in. So in this problem, I'm relying on Pythagorean theorem. Last problem was the special right triangles. We need to do Pythagorean theorem one more time though, because I don't know what this side length is. So we have 15 and 4 and then x. So we'll do that right here. I'm going to do 15 squared plus 4 squared equals x squared. 15 squared is 225 plus 4 squared is 16 equals x squared. And then 225 plus 16 is going to be 241. Now this is where we ask ourselves if we can simplify this. Can I do a factor tree? I'm going to look on my phone. I'm going to look at my calculator and see if I can divide a couple common things. I know by looking at it, it's not divisible by 2 because it doesn't end in an even number. I also know it's not divisible by 5 because it doesn't end in 0 or 5. So those are just some tricks. Again, we don't do a lot of those little tricks here because I assume you learned them in Algebra 1 or in, I don't know, elementary school. If you have no idea what I'm talking about when I'm like, I know that it's not divisible by 5, please come ask me outside of class. What I don't know though, and I'm just not as good with my factors, I don't know if it's divisible by 3. I don't know if it's divisible by 7. And I'm also going to check a couple more prime numbers. I'm going to check 11 and 13. And if it's not divisible by any of those, I'm going to assume that it's prime. I don't want to waste a lot of time on quizzes or tests. So for sake of today, I'm going to know that it's done in prime. But if I were you, I'd try and check a couple of those numbers and then move on. I'd rather take an L for minus like half a point for not simplifying it than waste 20 minutes because I couldn't find what it was divided by. So I'm doing 241 right now divided by 3 to check that. Nope, not divisible by 3. 241 divided by 7, also not divisible by 7. I said I'm going to try 11, so also not divisible by 11. And I'm going to try one more. I'm going to do 13. It's not divisible by any of those. So I tried every prime number between 0 and 15. I think that's appropriate. I guess technically you could go up to 20, but I'm going to assume that I would have found it by now, and it's not there. So square root of 241 is a good enough answer. So I'm going to go fill that in up here. Okay. Now we already found area. So the last thing we have to do perimeter, and it's just adding up my sides. So 15 and 4 and root 241. So I'm going to do that over here. Perimeter equals 15 plus 4 plus root 241. Now, I cannot combine root 241 with anything. Nothing else has that same thing under the radical. I can, however, combine 15 and 4 because they both don't have radicals. So those are like terms. So that becomes 19. And as I already told you, I want this to be in not a decimal. I want it to be in simplified radical. So this is as good as an answer as I'm going to get. I'm going to write my unit of centimeters behind it. And 19 plus root 241 is the best answer I can give. I'm also going to make a little note to myself that says no decimals. And I'm going to say not okay. So it's not okay for you to give me a decimal here. I want it as a radical. Okay, anybody have any questions yet? Okay, I'm gonna be quiet and I want you to try the next two. So I'm gonna jump back on in 1, 2, 3 minutes and do them all together so you'll get the full problem done. But I'm gonna be quiet and I want you to see what you can do with both of those before I jump in to help you, okay? Anybody have any questions before I do that? All right, good luck, take a couple minutes. Okay, take a minute, finish the one that you're on, because I'm going to jump in with you guys. Okay, so I did one, again, like each of the others. I did one triangle, I did one parallelogram, so I'm going to do the triangle one first. I'm actually going to do area first here because I see area pretty plainly. I see my base is 13. And then my height always comes from a vertex and then is perpendicular to the opposite side. I can't be perpendicular by having my line come where the 13 is. So the line that's perpendicular is actually outside the shape. If you remember back from chapter 15 or chapter 5, our altitude can go outside the triangle, especially when it's coming from an obtuse angle. So that's okay. And that's actually just like what happens. So my area I'm going to do first because I've got my height is 9 and then my base is 13. So I'm going to do area over here. Area equals 1/2 base, which is 13 times height, which is 9. I actually can't simplify that down. So I'm going to do 13 times 9 and I get 117. So you get 117 over 2, but you can make that a decimal and it's a really nice decimal, 58.5. And this unit is centimeters. Don't forget to do centimeters squared. I almost forgot just now. You can leave it as a fraction. You could also make it a decimal. I'm okay either way here. So if all I asked was for area, I didn't have to find anything else. However, I do want perimeter, so now I need to do some solving. Anybody have any questions with area before I move to perimeter? Okay. So I'm going to find the missing sides. I'm going to start by finding this side right here. And my initial thought was Pythagorean theorem. So I'm going to do Pythagorean theorem. I've got 9, 9, and then x. So we'll do 9 squared plus 9 squared equals x squared. 81 plus 81 equals x squared. 81 plus 81 is 162. Oh, and I know that at least divides by 2. 2 and, 81. And I know 81 is 9 and 9. Oh, stop. I have my pair of numbers. I mean, you could go down to 3 and 3 and then take out 2 3s, blah, blah, blah. But the minute I see a match, 9, I'm going to stop and I'm going to take that out. 2 doesn't have any friends, so it has to stay on the inside of my radical. So I've got this to be 9 root 2 equals x. Again, I do not want a decimal. I want a simplified radical. 9 root 2 is the most simplified radical I can make radical 162 to be. So this is 9 root 2. Now, some of you might...
Could you also do...
Oh, tell me what I also...
This is why... Could you also do the special triangle that way?
Tell me what you did, Allie.
I just did 9 times root 2.
And why were you allowed to do just 9 times root 2?
Because the 2 legs are congruent. So it's a 45, 45, 90 triangle.
Perfect. Allie, I love that you read my mind. I was about to say that. So perfect. You exactly could do this. I just thought off the top of my head Pythagorean theorem, but you could have seen special right triangles first, and either one gives you the exact same answer. Way to go, Allie. And that was way less work. What Allie did is way less work than what I did. So honestly, special right triangles is the real winner here. Now, the last leg, we do need to do another Pythagorean theorem, or if you didn't do Pythagorean theorem the first time, you definitely need to do it now because I don't have a special right triangle this time. I have to look at not just the shaded part. I can't just look here at the shaded part. I also need to look at the entire empty part as well to get a big right triangle. You cannot do Pythagorean theorem if it's not a right triangle, and you currently do not know in your math career how to do that. I'll teach you how to do this come pre-cal, but you don't know how to do that yet. So if we're not in pre-cal and we don't know how to find that missing side, we have to use the right angle. So I've got my right angle. I've got this whole side, which is 9 centimeters. We used that a minute ago. And this side is not 13 or 9, it's 13 plus 9, which is 22. So I've got 9, 22, and then we'll just call this x. If you hate using x twice, call it y. I don't care, whatever you want. So I'm gonna do 9 squared plus 22 squared equals x squared. Again, I have to use the entire triangle, not just the shaded part. 9 squared is 81, 22 squared is 484. Equals x squared, and 81 plus 484 is 565. Now, since we've already sat through me trying to figure out what 241 was, I'm not going to make you do this one. This one is also a perfect square or a perfect prime number. I can't simplify it down. So root 565 is the best answer for this. Again, I don't want a decimal. You can't simplify it. There's nothing that can go on the outside because there's no perfect squares inside of it. So my longest leg is root 565. Let me erase some of this nonsense on this picture. Okay. Now, we already did area a minute ago, and I liked to do that before things got too messy, so I knew exactly what I was using. The last thing we're going to do is perimeter, and I just have to do all my sides added up. And again, it's the sides of the shaded figure. So 13 plus 9 root 2 plus root 565. Perimeter is 13 plus 9 root 2 plus root 565. We actually can't do any more simplifying here. That's as good as that one gets. 13 has no other real number with no radical to combine it to. The other 2 radicals are root 2 and root 565, and those are not the same, so they don't get to be like terms either. And I know this is messy, 13 plus 9 root 2 plus 565, but that's okay. That's my answer. I'm just going to throw my unit at the end, centimeters, and call it a day. All right. Anybody have any questions on this third problem on this page? All right, last one we have is another parallelogram. So let's do this and then go to the back side. All right, so with this parallelogram, I've got 24. Oh, and I've got all these cute little congruent marks, congruent, congruent, congruent. So I'm gonna mark 24 on all of these sides. Ooh, pause, time out. That means I've got all my sides. So I can find perimeter super easily by doing 24 plus 24 plus 24 plus 24, or 4 times 24. Again, I like to do whichever one I can do easiest before things get really messy and really clogged up with numbers. So 4 times 26 or 24 is 96. And this unit is inches, and perimeter is just inches, not squared, not cubed, no nothing. Okay, 96 inches. All right, pretty easy. Any questions yet? Okay, now I gotta look at this other triangle. So we have to find my height before I do anything crazy. So I'm gonna take this triangle down. I know I've got a little right angle, and I know that the hypotenuse is 24. What I also know is if this angle is 60, then its opposite angle is also 60, which makes this angle on the inside 60. And it makes the other angle 30. So now I have a 30, 60, 90 triangle, which I haven't practiced yet. Does anyone remember how I go from the hypotenuse to the short leg on a 30, 60, 90? How do I go from the hypotenuse to the short leg on a 30, 60, 90?
Divided by 2.
Divide by 2. Very good, Jane. Divide by 2. So 24 divided by 2 is 12. And then now I have to go, that wasn't my height side. That was just my short leg. So now I need to go to my long leg to find the height. Anyone know what I do to go from the short leg to the long leg?
Would you multiply by root 3?
Very good. We multiply by root 3. Good job, Ella. Times root 3. And 12 times root 3 just stays as 12 root 3. So I'm going to leave it there. And this is my height. And I'm going to actually try and write it on my picture. 12 root 3. There we go. All right, again, I'm going to get rid of some of this highlight circle nonsense that I don't need, because now I have enough to find my area. I have my height. I have my base. So area of a parallelogram is just base times height, which is 24 times 12 root 3 in this case. I know that radicals aren't always our like strongest suit. So just a reminder that when we do radicals, you can multiply the numbers outside the radical together, and you can multiply numbers inside radicals together. I don't have anything else inside the radical besides this root 3, but I do get to do 12 times 24, which is going to be 288. And then the root 3 stays by itself. And I've got my units of inches squared. All right. All right, so we did 4 good examples of this front side. So now you've got some examples to use for your homework. Notice that I showed you my Pythagorean theorem. I showed you my special right triangles. If you just do like 4 times 24 on your paper or 24 times 12 root 3, and I don't know where these numbers come from, you will not get full credit. So please make sure you show all this work, even a little picture of your triangle, even some Pythagorean theorem. I don't need every single step, but I got to see some work to know where these problems are coming from. Any questions on the front? All right, let's jump over to the back. And the back's actually super simple. So I've just got 3 more things, but 2 of them are the same. So I've got area of trapezoids, and then I've got areas of rhombuses and kites. Looks like I combined rhombus to be rhombi, but whatever. I'm not great with English, so that's why I'm your math teacher. First is area of a trapezoid, which we have probably looked at before, probably back in middle school or elementary school. I don't quite know, but I know that I didn't see this for the first time in high school. And if it is the first time you see it, it's not too hard. It's a lot like a triangle. Area equals 1/2 height times base 1 plus base 2. The difference in a trapezoid is you have 2 bases. And remember, the bases are the sides that are parallel to each other that never cross. I have to do both bases added together and then times that by height and by 1/2. So I wrote like a triangle, just 2 bases, not 1. So whatever cute way you want to remember it, I think of it just like a triangle. Here's a little picture to help you represent it. I've got one base, which is the short one on top. I've got one base, the one on bottom, and they're not always on top and on bottom. It's just the 2 parallel sides. And then the height is the perpendicular distance. Perpendicular means it makes a 90-degree angle with both bases. So it kind of goes right through your trapezoid. It's never going to be one of the sides. So if I give you this side, we have to use that to help us find the height. It's not that, because that's a slant distance. I want a perpendicular distance, like a true distance if I measured from one point to another, how far apart they are. The height must be perpendicular to the bases. So I think I've talked about perpendicular height a couple times now. Perpendicular, perpendicular, perpendicular must come from a 90-degree angle. Okay, so we'll use those examples in a second. Any questions yet? Okay, the last one, rhombi and kites, this is the same formula. We're allowed to use this one for both of these because these shapes have diagonals that are perpendicular. So because my diagonals of kites and of rhombuses are perpendicular, we're allowed to use this formula to find area. Area equals 1/2 diagonal 1 times diagonal 2. So you can call those diagonal 1, and this one is diagonal 2. And they're being multiplied together. A big mistake I see sometimes is you think since there's something between them that we add them. No, 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 multiply them. So if I go look at this picture, I've got my diagonals. I've got like diagonal 1 goes from one corner to another. Diagonal 2 goes from the other 2 corners across from each other. It's the entire length, not just like to the halfway point, the entire distance. You also don't have to use this. You can treat a rhombus like a parallelogram because it is a parallelogram. Oh, I'm sorry, that's so messy, but that says like p-gram. You can treat it like a parallelogram, or you can even find the area of one of the little right triangles. So like this is a right triangle. And if you found the area of this triangle, it's congruent to all the other ones. So you just multiply that by 4. So that's a possibility that you can use. You don't have to use the formula I give you. Same thing with kites. The diagonals are labeled kind of funny here. So the diagonal 1's like the long diagonal, and then diagonal 2 is like the vertical diagonal, the short one. So they're labeled funny, just wanted to give you a heads up. And again, you don't have to use this formula. You cannot treat it like a parallelogram though, because it's not. So I'm going to say not p-gram. You cannot treat this one like a parallelogram, but you do have little congruent triangles in here. So if you wanted to, you could find distances and areas of those and break it apart. Definitely an option. For these last 3 examples though, I'm going to use the formulas that I gave you because I want to show you A, how easy they can be, and B, let's get in the practice of using them. Anybody have any questions yet? All right, last 3 examples. All of these also just say find the area, so there's no need to find perimeter. Now these first 2 are on a coordinate plane, so you might be like, come on, Miss White, we didn't do anything on a coordinate plane. Why are you making us do more work now? Stop, because I argue that this is not harder. I actually argue this is easier. When it's on a coordinate plane, and I don't have to use distance form, like if it's not a diagonal, if it's nicely horizontal or vertical, you can just count the spaces. So like while I could find distance formula between points E and H, I can also simply count 1, 2, 3, 4. This base is 4 units long. Okay, seems simple. Let's look at the other one. This one's also vertical, so I'm just going to count 1, 2, 3, 4, 5, 6. 6 jumps. Also easy. Okay, one base is 4, one base is 6. Now the height isn't really a height in this case. It's going to be horizontal because if my 2 bases are vertical, then that means the perpendicular to that is horizontal. You can look at any of these horizontal lines. You can look at this one. You can look at this one. You can look at this one. I could do this 4 days, whichever one you want. I'm going to choose the top one because it is perpendicular to both bases. And if I do my little jumps, 1, 2, 3, 4, it is 4 jumps. Okay, cool. So I have all my pieces. Remember that area of a trapezoid is 1/2 height, base 1 plus base 2. Don't forget that plus. So we're going to do it with the points that we have. 1/2 of 4, because that's my height, times base 1, which is 4, plus base 2, which is 6. I can add 4 and 6 together to be 10. And then I'm actually at the same step going to do 1/2 of 4 or 4 times 1/2 or see if there's a common factor, which there is. And that becomes just 2. So I've got 2 times 10. And 2 times 10 is 20. So my area here is 20. Now, I know I don't have units written. If there's nothing written, we just literally write the word units and you have to square it. I really want you to remember that areas are squared. So I need you to fully write out the word unit or a U with a square on it. I want to see that. Anybody questions on that one? Okay. Now I've got a kite. Again, you might be like, oh, it looks like we're gonna have to do distance here to find this or this. No, because I don't need perimeter. I just want area. And we just learned that area of a kite is 1/2 diagonal 1, diagonal 2. You can put a little multiplication sign. That's where people get confused though, so I choose not to. You can also just do parentheses for multiply if that makes you happy. Again, whatever floats your boat. Doesn't really matter to me. Let's look at the diagonals though. We have to go across the shape. So I'm gonna go from B to D. And that's 1, 2, 3, 4 units. Okay, easy. And then now I'm gonna go the other diagonal, which is A to C, which is, oh, another nice straight horizontal line. 1, 2, 3, 4, 5, 6. 6 units. Perfect. One of my diagonals is 4, the other one is 6. So I'm gonna do 1/2 of 4 times 6. I should have mentioned this in the other classes, so hopefully they watch the video or I'll correct them tomorrow. But you do not get to distribute this 1/2 in. A lot of people are like, oh, well, I'll do 1/2 of 4 and then I'll do 1/2 of 6. No, 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 no. You get to do 1/2 of one of them. It's all being multiplied together. So it's 1/2 times 4 times 6. If you do 1/2 and 4 together, then you've already used up your 1/2. You don't get to use it again. You've already used it. So I'm going to do 1/2 of 4 because I know easily that's just going to be 2. And so 2 times 6 is going to be 12. And again, I have no units, so either do a U squared or unit squared. Any questions on that? Okay, I got one more. This last one says find the area of the rhombus. So again, it's a rhombus, I know that. I see that this whole diagonal is labeled 7 and 7. Remember that in rhombuses, like a parallelogram, like a square, like a rectangle, my diagonals bisect each other. This is 7, this is 7. Unlike other four-sided shapes like a square or like a rectangle where their diagonals are congruent, the diagonals of a rhombus are not congruent, but they bisect each other. So if this is 7 and 7, then that means together that whole diagonal is 14. Similarly, this diagonal, I know from this, from the middle to the outside is 8. So then that means the other side is also 8. Because it's bisected. So if one side's 8, then the other side's 8. So that makes this whole diagonal 16. Okay, really cool. Again, I've got my diagonal, so we get to do area equals 1/2 diagonal 1 times diagonal 2. And in our case, that's going to be 1/2 16 times 14. Again, you can enter this in your calculator, but I like to simplify out here. So 2 and 16 have a common factor of 2, which gives me 8 times 14. And 8 times 14 is going to be 112. Ooh, this time it did give me a unit, so make sure we do meters. So 112 meters squared is the area for this rhombus. Again, there's other ways to find it, but these are the easiest ways to find the area, especially when I give you a diagonal. I want to go over, I haven't dismissed you yet. I don't know if you guys can hear people leave, but I heard someone leave. So I haven't dismissed you yet. I'm going to dismiss you momentarily, but I need you to stick with me for a second. Does anyone have any questions on these notes before I jump away from this? Okay. The last thing I want to remind you is your homework is right here in today's folder, Monday the 19th. It is a two-sided worksheet. It is due on Thursday, because that's, sorry, not Thursday, Wednesday. The next time I see you is Wednesday, not tomorrow, Wednesday. Now, there's a word problem at the bottom. However, you are capable of doing this word problem. If you don't do the word problem, you will not get full points on your homework. Same thing on the back. There's two word problems back here. Just draw a picture of what it tells you. A trapezoid has base lengths 6 and 15. Draw a trapezoid, label its bases 6 and 15. Use the rest of the information to find what's missing. I go over your homework with you, but like at this point, you guys are almost juniors and I need you to take like ownership of what you're learning and who you are as a student. You can't just like skip out on the hard ones. Everybody's got to do everything. Homework front and back, and this mirrors your notes. Front side is 10-1, just like the front side of your notes. Back side is 10-2, just like the back side of your notes. I'm going to be on Zoom for the rest of class, so if any of you need any help, let me know. If not, I need you to get started on your homework, and it's due on Wednesday. I'll be around Wednesday and Friday morning if anyone needs help. I am going to stop my recording.